Hello everyone. The title of this video is Solve Rational Equations that Involve Functions. Alright, so in this video I'm going to be doing 4 exercises, 4 examples with 3 parts each. And these exercises are taken directly from a free online textbook at openstacks.org. And it's their Intermediate Algebra 2nd edition book. I'm in section 7.4 titled Solve Rational Equations. And I'll be working on exercises 231 to 234, parts A, B, and C for each of these 4 exercises. So example 1 in the video will correspond to exercise 231. Example 2 will be 232, example 3 will be 233, and example 4 will be 234. And I'll have timestamps for when each example begins in the video in the description of the video, and in the description box below. So if you want to bounce around, hopefully those timestamps will help you navigate a little more easily. Alright, and when I bring up a new example, try pausing the video and working on the problem yourself. Alright, see how well you do. So try to complete the problem yourself, then play the video again and watch me do it. That way you can compare, your work to my work, see if you got things correct or incorrect, and get a gauge as to how you are grasping the material. Alright, so for this first example, see we're asked to, we have for the rational function f of x equals x minus 2 over or divided by x squared plus 6x plus 8, do the following. Alright, so part A is find the domain of the function. Alright, so I pull this up. Alright, here's again example 1. We're given this rational function. Remember, a rational function is y equals or f of x. They got function notation here, and I'm hoping you recall this, what this means, right? F is the name of the function, and x, right, is the input variable, and f of x equals the output, right? This rule over here, x minus 2 divided by x squared plus 6x plus 8, is just describing how you take the input value and get the output value, right? How you take the x value and find the y value, if you want to call it that, or the f value, the value of f. Alright, yeah, so part A was state the domain. Now, remember, the domain of a function is the set of all, I'll say, allowable, right? Set of all allowable inputs for that function, right? And remember, inputs are, values of x here. Well, if we look at f of x, so we look at this function, how we calculate the output. X minus 2 in the numerator, x squared plus 6x plus 8 in the denominator. Well, I'm going to start off by factoring the denominator completely. So x squared plus 6x plus 8, and again I'm assuming here that you know how to factor polynomials. That would factor to x plus 4 times x plus 2. Right, that would be x squared plus 6x plus 8, and you can FOIL, multiply these together and see that they are indeed the same expression. So remember, recall that denominators can't be 0. All right, so one more little note here before I actually get into writing the domain. All right, recall that denominators cannot be 0. Right? Because if you have any denominators of 0, that means you're dividing by 0. And division by 0 is an undefined operation. You'll have an undefined expression. I would like to be able to plug in values of x and actually get defined values of y, or values of f, defined outputs. So hopefully it's obvious here that we want, so x plus 4. So the question is, when is the denominator here 0, right? When is x plus 4 times x plus 2 equal to 0? And hopefully, you see the answer right away. Remember when we have a product equal to 0, then either factor of that product could be 0. So either x plus 4 is 0 or x plus 2 is 0. And when x plus 4 is 0, subtracting 4, that means x equals negative 4 there. And when x plus 2 is 0, subtracting 2, we get x equals negative 2. These values, right, these two values right here, negative 4 and negative 2, these do not belong to the domain. Right? Reason being is that they make, when I plug these values in, I would be dividing by 0. I would have an undefined expression. Now the numerator can be 0. That's fine. All right. I see too often people saying, like for an example like this, x can't be positive 2, because the numerator would be 0. The numerator can be 0. Numerators being 0 is fine. Denominators, right, what you're dividing by, can't be 0. Alright, so here are a couple ways to state the domain then of this function. So one is in what's called set builder notation. So the domain, I'll say the domain of f, right, the name of the function, is, and then I write little curly braces for the name for the beginning of a set. And then we describe the values in the set here. So usually, my domain is talking about inputs, right? X values. So the domain of f contains values of x. So I put the name of the variable I'm describing such that, and then sometimes there's a little bar or a colon. So the domain of f contains all values of x as long as, or such that, alright, this little bar here, or again a colon, x is not equal to negative 4, and then we could put a comma, but I'll just say as long as both of these can't happen, it's, x can't be negative 4, and x can't be equal to negative 2. Both of these have to be true. That's why I put and. Right? Now you could just put a comma as well. I mean, I've seen that's allowable. Yeah, and this is a totally valid way of expressing the domain. Right? And again, this is called set builder notation. I have the variable I'm describing. I can plug in any value of x I wish, as long as, and then over on the other side of the bar, what are conditions on that variable. Right. So this is every value, every real number except negative 4 and negative 2. Now, an alternate way would be with interval notation. Right, the domain of f. If you think of a number line, you don't have to think of a number line, but if I was to think of a number line and think, oh, well, let's say these are the possible values of my variable x. What we just said is that x can't be -4, so I'll put like a big hole above that. And also x can't be -2. I put a big hole above that. But it can be anything else, right? So any of these values to the left of -4 are in the domain. These values between -4 and -2 are also in the domain. And the values to the right of 2 are all those values I just highlighted, except where the holes are in the domain. So if I'm writing the interval notation for this picture, technically there are 3 pieces, because these holes break up the graph, right? Well, they break up the intervals. So the first piece would be from -infinity, right, to the far left, up to -4, but not including -4, right? So parentheses on that. Or, right, and then in union with, remember when there are multiple pieces, multiple intervals, you're separating them with the union symbol, right? This is big U, and again, I'm assuming you've seen interval notation before. Then the second piece here, the numbers between -4 and -2. So -4, comma, -2 with parentheses on both ends, again, because -4 is not in the domain, -2 is not in the domain. And then there's this third last piece, right? So another break, right? So another union symbol. And then the last piece goes from -2 to positive infinity. And then a parentheses on -2, right? Because it's not in the domain. And always, always, always parentheses on your infinities, because infinity is not a number. And this is also an equally valid way of describing the domain, right? You're just stating values you can replace the variable with, right? You're just stating allowable values for the input. Okay. Alright, so that was part A. Let's just read part B. Part B. Solve f of x equals 5. Right, solve this equation. F of x equals 5. Alright, so let's bring the page back up. So same function, right? Same function, and I'm going to leave, when we're asked for part B, solve this equation. F of x equals 5. So this is just asking, for what inputs is the output going to be at 5, right? For what inputs, right, the x values, is the output, which is f of x, five. That's the same thing, right? That would be asking this question. Alright, well, simply enough, just replace, f of x. What is the value of f at any x input? Well, that's this expression here, right? This fraction here. Or I'm going to write it factored. Oh, no, you know what? No. Actually, I should start from the beginning and write out the steps, okay? The steps for solving a rational equation, or an equation with a fraction. So we have x minus 2 divided by x squared plus 6x plus 8. Right? And when is that, f of x, when is that equal to 5, right? And I'm solving for x, trying to find values of x that I can plug in to make this left side, equal 5. Alright, so the steps in solving a rational equation, an equation with a fraction. First, I would factor all the denominators completely, which I've already done, right? And I'll write it again. Factor all the denominators completely. Oops, there should be another E in there, sorry, completely. So there's only one denominator, right? X squared plus 6x plus 8, and I've already factored that for you earlier, right? So this is x minus 2 in the numerator, and then we have the factors of x plus 4 times x plus 2 in the denominator. And we still have the equals 5. Right? All right. Then we find the least common denominator, right? The least common multiple of all the denominators, otherwise known as the LCD, which I have referred to in other videos, and I'm assuming you know what that stands for, least common denominator. Alright, so that's simple enough. Right? When there's only one denominator, that is the least common denominator, right? So for this example, the LCD is simply the product of x plus 4 and x plus 2. Okay. Right, then we multiply both sides of the equation by the LCD. And I guess one thing I should have pointed out too is remember, right, off to the side here, recall that the value of x can't be negative 4 and the value of x can't be negative 2, right? Just keep that in mind. Right, that's why they had us do the domain of the function earlier. Because if x were negative 4 or negative 2, you'd be dividing by 0. And if I multiply both sides by this LCD, you know, as long as x is not negative 4 or negative 2, we're fine. Right? We'd be multiplying both sides by some non-zero number. But if x were negative 4, or if x were negative 2, we'd be multiplying both sides by 0, and that is not good. That's not a good step to perform when equation solving. All right. Okay, so I take, the left side, which is just this fraction, and multiplying this whole, there's only a single fraction over here, a single term, and I multiply that side by the LCD, and same thing with the right side, right? We have equals 5, and I'm taking, now it's just the number 5, I don't need really parentheses around it, but taking the whole right side and also multiplying by the LCD. X plus 4 times x plus 2. Now the whole point of multiplying both sides by the LCD is so that the denominators will cancel. Alright, look at this left side here. See the x plus 4 in the denominator, x plus 4 in the numerator now when I multiply by the LCD. X plus 2 in the denominator, x plus 2 in the numerator. So all I'm left with now on the left side is x minus 2, right? Because the denominator went away. Now on the right side, this is 5 times x plus 4 times x plus 2 was x squared plus 6x plus 8. And then distributing the 5 would give me 5x squared plus 30x plus 40. So see what happens. The reason we multiply both sides by the LCD is so then I'll have, instead of a rational equation, right, instead of an equation with with fractions and denominators, I now have a simple looking polynomial equation. Right, and that's the final step, is solve the resulting polynomial equation. And of course, check your answers, right? That should be assumed. You should do that all the time, but yeah. Solve the resulting polynomial equation. And then, of course, then check solutions, right? Back in the back in the original equation, always, right? All right, so this is a quadratic equation, right? So remember how to solve polynomial equations. Again, I'm assuming that you do. Start off by taking everything to one side, and I'll switch sides here, put the 5x squared on the left, and then I would subtract x to give me positive 29x. I would add 2, give me positive 42. And this is equal to 0, right? So I take everything to one side and 0 on the other. All right. So now I have quadratic equation, and let's see if we can factor this. Now what I'm going to do is I'm going to do the b squared minus 4ac test to see if that's even factorable. So remember, b is the coefficient of the first powered term, so take 29 squared minus 4 times a is the lead coefficient, 4 times 5, and then c is the constant term, positive 42. And see if if this value is a perfect square, right, then I will be able to factor this. So I'm just using a calculator off to the side here. 29 squared minus 4 times 5 times 42. That is 1, which is definitely a perfect square. All right, 1 is 1 squared. All right, so that means that this is factorable. All right. I can break this up. One factor's got to have 5x. The other factor's got to have just 1x to give me the 5x squared. Right, and then I need to break up 42 so that when I FOIL, I'll get 29 x. Right, I'll get 29x. Let's see, that'd be 2 times 21. 1 and 42 won't cut it. 2 and 41. 2 and 21 doesn't cut it either. 3 and 14. Yes. I would need plus 3 here, plus 14 here. Alright, because that would give me 15x plus 14x, which would be the 29x. Alright, and then you have 14 times 3 is 42. Okay, so now I factored this, and we use the zero product property. Remember, a product is only equal to 0 when each factor is 0. So by that zero product property, either 5x plus 14 equals 0 or x plus 3 equals 0, and we get our solutions. So either x equals negative 14/5 or x equals negative 3. And if you did everything correctly, as long as those values are in the domain of the function, which they are, right? Both these values are in the domain. Then it should be, they should be good, right? Neither one of these is negative 4 or negative 2. So when I go to check, right, this should work out, and this should work out. I'll do at least the negative 3, right? So go back to the original equation, maybe even in the factored form. replace x with -3. The numerator would be -5. The denominator would be 9 minus 18 is -9 plus 8 is -1. You have -5 in the numerator, -1 in the denominator. -5 divided by -1 is +5. That works. -3 works. And I leave it to you to check that -14/5 works as well when you replace x with -14/5. Okay, so that's it. That's the answer to the question. All right, when they're saying solve f of x equals 5, the values of x, pardon me, the values of x that I can plug into function f and get an output of 5 are -14/5 and -3. All right, and that leads me directly into part C. All right, see part C. Find the points on the graph at this function value. All right, so at the value of 5. So again, outputs 5, and we now know the inputs that give us an output of 5. So we know the x coordinates and y coordinates. So part C, all right, so for part C, so based on part B, we know now that points, x value -14/5, comma, y value 5, right? Input -14/5, output is the value of f, that's 5. This is a point on the graph, and input -3, output 5 is also on the graph. See, so are on the graph of y equals, f of x. Y equals x minus 2 divided by x squared plus 6x plus 8. Now let me show you. Now you can make a graph by hand, but I'm just going to show you a nice free online graphing calculator where you can graph this particular function that we're given, this f of x. Alright, so let me go back to the websites, and I've got a website up called desmos.com, desmos.com. Yeah, it says, it's a free online graphing calculator. All right, and then off to the side here, in one of these spaces, I'll put the function we were given, f of x equals, and then in the numerator, I'll put in parentheses x minus 2 divided by, and then in the denominator it was x squared plus 6x plus 8. All right, you see all these red points that just showed up here? The graph is in red. There's a picture of all the ordered pairs that are contained in this function, all the inputs and outputs that satisfy this rule. So we can see, I can highlight some points here, like here, 2, 0, right? If x were 2, the value of f would be 0, right? You have 2 minus 2 in the numerator, that'd be 0, and then something that's not 0 in the denominator. Here's another one, 6.899, comma 0.051, 0, comma -1/4, right? If x were 0, the output would be -2/8, which is -1/4, right? And so on. And you can find other ones. All right, so what I'm going to do is put in those points I just said would be on the graph, with a y value of 5. And in fact, let me zoom in up here. The y value is the vertical axis, and there is this y value of 5. All right, and we'll see when I plug in some points here and off to the side in the second box. I'm just going to put one of those points was -14/5, comma 5. And look at that. You see how that blue dot showed up on the graph? Right? -2.8, which is -14/5, comma 5. and that is on this red graph. It's clearly on it. And then the other point we said would be on it was -3, 5, right? You know, when the input was -3. Now let me erase the other point, and you can very clearly see this green point show up, -3, 5 here. That is on the red graph. It's on the graph of this function. Right. So very nice. And if you want to make it bigger, you know, just hide the expression list, and you can move this around like any map. And again, you can very clearly see that this point is on that the graph of that function. Is one of the ordered pairs that satisfies this rule. Okay. Next, all right, that's all example 1, number 231. And then the rest of these are pretty similar, right, just with different functions. Example 2 will be number 232. Right, for the rational function f of x equals x plus 1 divided by x squared minus 2x minus 3. And we're asked to do the same stuff, right? So for part A, again finding the domain of the function. All right, so back to my paper. Right, here was the function from example 2, and for part A, let's state the domain of this function. That's again called f, right? So what's the domain of f? Well, once again, pretty easy. Just you're only focusing on denominators here, right? When is the denominator going to be equal to 0? And then those values won't belong to the function. Alright, so the numerator is simply x plus 1. I'm not doing anything with the numerator. And the denominator factors, x squared minus 2x minus 3, that would factor to x minus 3 times x plus 1. Right. So if you look at just the denominator, the factors are x minus 3 and x plus 1. So hopefully you'll see that very clearly x cannot be equal to 3, right, because that'll make this first factor 0, and therefore the whole denominator 0, or -1. So I'll just do that here. X cannot be 3, -1. Because if x were either of these values, you'd have a denominator of 0. So that's what I'll put in the domain. Alright, so the domain is any value of x I wish, right, the variable's x, as long as, or such that, in a little bar or a colon, as long as x is not positive 3 or not -1 either. It can't be either of those. So as x is not -3 and x is not -1. So there's one way to describe the domain. Again, another way to do it would be with interval notation. So there'd be all, the numbers I can use for x are from -infinity up to -1, but not -1. Or the numbers from -1 to 3, right, but not -1 or 3, so I got parentheses on those. Or the numbers from 3 to infinity. Right, and again, parentheses on 3. Either one of these is a perfectly valid way of stating the domain. Alright. Now, one thing you may notice is that the numerator has a factor of x plus 1. Right? It's already totally factored, right? So because I didn't need to do anything to it. The denominator has a factor of x plus 1. So I can cancel some common factors here, and we can say that f of x is equal to, and then remember when common factors cancel, they become the number 1, right? Anything divided by itself is 1. And I'll be left with 1 in the numerator divided by x minus 3 in the denominator. But just again, be careful. this is only, I can only do this for values of x that are not positive 3 or negative 1. Right? So I'm gonna think of f of x this way now, and that'll make solving, any equation I have later easier, right? Because the fraction's nice and simplified. But just remember, even though it looks like I can plug in negative 1, I can't, right? Because the way the function originally looked, I can't plug in negative 1, right? So yes, you can simplify the fraction, but you still can't use the values that aren't allowed from the original expression. Okay, I hope that makes sense. All right, then part B. All right, part B is solve f of x equals 1. All right, so we're solving f of x equals 1. Alright, so again, remember that x can never be positive 3 or negative 1. So if we end up with either of these numbers as a solution, then it's not a solution. Right? So f of x is 1 over x minus 3, and I want this to be equal to 1. I'm trying to figure out when that's equal to 1. Now it's probably obvious that when x is 4, this is working. But remember, the denominator is totally factor, it's just x minus 3. And then the LCD is obviously just x minus 3 here. When I multiply both sides by the LCD, when I multiply both sides by x minus 3, we get the following. The left side will just simply be 1, because the denominator, x minus 3 will cancel. And the right side will just be x minus 3. And then I would just be simply adding 3 to get x equals 4. And that's in the domain. 4 is in the domain, so this is good. And you can check this, right? 1 over 4 minus 3 is 1 over 1, which is 1. That works. And then part C, using these, now they're just asking, find the points on the graph. If I was to graph this function, right, and I'll type it in the way it originally looked. You should always look at the way it originally looked when graphing. But the points based on part B here, this is telling me that when the input is 4, the output will be 1. So the point 4, 1 will be on the graph of this function, right, which I will show you. All right, the point 4, 1. So again, back to the Desmos website. Let me just clear these out. Back to the home here. And again, I'll type in the function the way we were given it. Right? We had f of x equals, and then in the numerator, x plus 1 divided by, and in the denominator we had x squared minus 2x minus 3. Right. And let me show you that x can't be 3 or negative 1. Right? Like even below, if I just typed in f of 3, it's going to say, see, undefined. Right? You can't plug in 3. If I type in what's f of negative 1, and you see it says undefined. Right? Even if I go over here to when where x is 3, right. Well, there's no points actually. But when I go to where x is negative 1, you'll see like a missing point. Right here, let me click on this right there. There, see the point is a hole. There's a hole in the graph. Negative 1, comma, undefined. And you see how where my cursor is, there is an empty point. At x equals 3, there's something called a vertical asymptote. right, that the graph will never touch. But again, we're not going to get into graphing this stuff. I just want to point out that, you know, -1 can't be plugged in, 3 can't be plugged in, and then from part C, you know, we solved that equation. When was f of x equal to 1? And that was when x was 4. So 4 comma 1, see that red point just pop up? See, 4 comma 1 is on this purple graph, is on the graph of all the ordered pairs that satisfy this rule, that belong to this function. All right, and that should happen, right? If you're solving these equations correctly, you know, the ordered pairs you're finding, the points you're finding should be on the graphs that you graph here in this on any graphing calculator, not just this one. Great. All right, example 3, which is exercise 233. It's for rational function f of x equals, you know, the numerator is 2 minus x, denominator is x squared minus 7x plus 10. Again, part A is find the domain. All right. So back to my paper. Okay, so there's the function we were given, and this is what I'm going to type in when I graph it. Right? So f of x equals 2 minus x divided by x squared minus 7x plus 10. And part A is what's the domain? Where are the allowable values of x? All right, the numerators, you know, I'm just going to keep the numerator the way it is for right now. 2 minus x. Denominator factors. That factors to x minus 5 times x minus 2. All right, so I'm hoping it's clear that if x were 5, that would be bad. So x can't be 5, right? That'll give me a denominator of 0. Same thing with positive 2. Right? The denominator would be 0. So the domain of this function is I can replace x with anything I wish as long as x is not 5 and also x is not positive 2. Or put 2 then 5 if you want, whatever order. Or if you want to do interval notation, you know, the values I can plug in are the values from -infinity up to positive 2, but not including 2, or the values from 2 to 5, not including either one, or the values from 5 to infinity. Right? You know, either one, you know, set builder notation or interval notation are perfectly fine. Alright, now something else I'm noticing is that this expression, right, 2 minus x, and this factor down here, x minus 2, those are opposites. And remember what happens when you divide opposites, they become -1. So we can simplify this, right? So what I'm going to do now is think of f of x, you know, if I simplify it, it would be -1 over x minus 5. And when I go and solve equations and junk, I'll use this. But you have to remember that, yes, it looks like I can plug in 2, but I can't because of the way the function originally looked. Right? X still can't be 5, and it still can't be 2. All right, so I'm going to think of the function this way, you know, for part B. All right, now part B is solve f of x equals 2. Right? When is the output? Right? When is the value of this function equal to 2? So part B, when is f of x equal to 2? Like I said, f of x is this expression here, what we started with, but you can simplify it to, you know, -1 over x minus 5. And when is this equal to 2? We'll solve for x. Right, just remember though, can't have 5 or 2 as a solution. Right? 5 doesn't belong to the domain, 2 doesn't belong to the domain. Alright, so LCD is obviously x minus 5. Right, I multiply the left side by x minus 5, the right side by x minus 5. X minus 5's cancel on the left side, we'd have -1. When I multiply these two, we'd have 2x minus 10 And then adding 10 gives me 9, divided by 2 gives me 9 halves. Right? X equals 9 halves, 4.5. So there's the value of x, there's the input. That would give me 2 as an output. And then for part C, use your results in part B to say what points would be on the graph. Well, the point, x value of 9 halves, and then output of 2 would be, so 9 halves comma 2 would be on the graph of this function. And once again, let me show you. Right, so back to this and go over to the calculator, the Desmos. And again, I'm going to enter the function the way it was originally given to me. Right, 2 minus f of x equals, and then 2 minus x in the numerator, and x squared minus 7x plus 10 in the denominator. All right, so you're seeing the blue graph pop up, all these ordered pairs that belong to this function. And as I was mentioning, f of 5, see, is undefined. All right, f of 2 is undefined, right? So 5 and 2 don't belong to the domain. And then I want to point out the point that we just found in part B, 9 halves for x, comma, 2 for y, and you see that green point just pop up. There's the point 9 halves comma 2, or 4.5 comma 2, and you can very clearly see that that point is on the graph of this function. And you should be checking that. All right, and I've got one last example. And again, you see all these are the same. All these are very, very similar. All right, example 4, which is exercise 234. For the rational function f of x equals 5 minus x divided by x squared plus 5x plus 6. Again, part A is state the domain. Right, so that's just worrying about where the denominator is equal to 0. All right, so here I have it again. Part A, right? What's the domain? And once again, I'm going to leave the numerator the way it is for right now. 5 minus x. Denominator would factor to x plus 3 times x plus 2. And this time there's no canceling. Right? Examples 2 and 3 had some cancellations. This one definitely does not. Alright, so hopefully it's obvious. Looking at the denominator, you have factors of x plus 3, x plus 2. So I can plug in any value of x I want, as long as x is not negative 3, and also x is not negative 2. Right, because either one of these values would give me a denominator of 0. Okay. Again, you can do this interval notation style. All the values you can use are from negative infinity up to negative 3, or everything from negative 3 to negative 2, right? Again, not including negative 3 or negative 2, or all the values from negative 2 to infinity, right? Just everything's able to be plugged in except negative 3 and negative 2. All right, and this can't simplify any further, so this is the way I'm going to keep thinking about the function when I go into part B. All right, now part B is solve the equation f of x equals 3. Right, f of x equals 3. So when is the y value 3, or the value of f3? When is the output 3? So we're solving f of x equals 3. Now f of x, again, you can write it the initial way or the factored way. Right? You have 5 minus x over, and I'll just write it the initial way, x squared plus 5x plus 6. When's that equal to 3? And the LCD, again there's only one denominator here. So I'm going to be multiplying both sides by that one denominator, right? X squared plus 5x plus 6. And do the same thing to the other side, x squared plus 5x plus 6. Now the left side, the denominator will cancel, leaving me with 5 minus x. Right side, I'm distributing the 3. 3x squared plus 15x plus 18. And then if I were to subtract 5 and add x, we'd have 3x squared plus 16x. And then, subtracting 5 would be plus 13 equals 0. And you can do the b squared minus 4ac check. You'll see that b squared minus 4ac is a perfect square here. This is factorable. I'm just going to keep it on this page. This would have to factor, and one of the factors would have to have 3x, the other would have to have 1x. And, plus 13 here, plus 1 there. Because then when I FOIL, I want 16x, right? There's 13x and 3x to make 16x. And now that I have a product equal to 0, hopefully it's obvious that x equals negative 13 thirds is a solution, and so is negative 1, right, when the other factor is 0. And both of these are in the domain, right? Neither of these values are negative 3 or negative 2, so they should both work when you check them out. All right. So now that I have the solutions to this equation, when is f of x equal 3, I can tell you some points on the graph of f. Right? And that's part C. Right? So points on the graph of f that I can tell from part B, points on graph. One of them would have an x value of negative 13 thirds and a y value of 3. So negative 13 thirds, comma 3. And the other point would be that I know from the previous part would be when x is negative 1, the output will be 3. Right, so the graph that I look at later should have both of these points, negative 13 thirds, comma 3, and negative 1, comma 3 on it. Well, let's see that happen. And I pull up graphing calculator once again, Desmos. I'll put in our function. I'll just put it in the way it originally looked, right? The way it originally was given to us is 5 minus x divided by x squared plus 5x plus 6. All right. And then once again, just to show you, f of negative 3, undefined. F of negative 2, undefined, right? So those values don't belong to the domain. Now, one of the points we said would be on the graph was negative 13 thirds, comma 3. And you're seeing that black point show up? Right, there it is, negative 13 thirds, comma 3. Right? Negative 4 1/3, comma 3. Then the other one's over here. Right? Looks like about negative 1. I mean, I could just show you here. See, negative 1, comma 3. And that's the other one we said was on here. Right? In part C, I said negative 1, comma 3 was also on the graph, and we can very clearly see that from this picture. Right. Wonderful. And that's it. Those are all very similar examples, right? Examples 1 through 4 here. Hopefully watching me go through these several problems help you out when you're working on similar work. And thank you very much for watching.